Hey class, today we're going to talk about single case studies, quasi-experimental research, and developmental research. You sound so excited. I can feel the excitement, especially when I said quasi-experimental research. You're like, oh yeah, yeah, yeah. So the first type of design that I want to discuss is the single case experimental design. Sometimes you have a very small sample size, but you still want to see if some independent variable, so for example, a treatment, has an effect on the dependent variable, whatever symptoms you're measuring. So you can use a single case experimental design to measure this. So before you give the treatment, before you give the drug, you want to have a baseline period. Remember, in an experiment, you have a control group and an experimental group, two groups that are basically equivalent. The only difference is the independent variable that you are administering, right? So the baseline period, this beginning time, right? So this period of 5 days, we just look to see how bad the symptoms are. But then we give the medication, and that is what's called a treatment period, right? Baseline and treatment. And that's right here. So we can see that there is a decrease in the actual symptoms that we see. Now, this could be due to any number of reasons. So sometimes what we do is what's called a reversal. So we take away the medication. And then we see, in this case, the symptoms increase again. And then we can reintroduce the medication or the treatment, and then we'll see that the symptoms decrease, right? So if I only do a baseline and a treatment, it would be called an A-B design. A is a baseline, B is a treatment. If I do a reversal, then it is an A-B-A design. I give them the medication, or sorry, I start with a baseline, no medication. I give them the medication, and I take away the medication. And if I were to reintroduce the medication, which would be one more treatment period, that would be A, B, A, B. And that is the single case design. You just learned 3 designs. Congratulations, it's that easy. So you have that baseline period, right? And that baseline period allows you to set a baseline. What are we comparing our results to? You introduce the independent variable, the drug, the treatment, right? And then you see that the symptoms might decrease. You do a reversal. So at this point, we're at ABA. And if we were to reintroduce the medication, it would be ABAB. And now we're going to talk about developmental designs. Developmental designs allow us to measure the effect of time or on some specific variable. So to start, let's talk about what a cohort is. A cohort is just any group of people that shares one defining characteristic, usually referring to the time in which they were born or the time in which they experienced a certain event, right? So if you think about generations, those are cohorts, right? We have millennials, Gen Xers, boomers. We're saying that they were children around a certain age, they were adults around a certain age, and so they are different than other cohorts. Or we can look at the different classes that I've had as potential cohorts, right? I have my spring 2020 class. I also have my fall 2019 class. All of them experienced a specific set of things at a certain time. So when we're looking at developmental designs, we're looking at cohorts and we're seeing how time affects certain characteristics. So you can have a cross-sectional design where you measure multiple cohorts at the same period of time. You can have a longitudinal design where you measure one cohort over multiple periods of time, and you could have a sequential design where you measure multiple cohorts over multiple time periods. So let's say I wanted to know if the people who take my class are happy, right? And if, my class makes a positive impact on their lives. So I take people who took my class 5 years ago. I take people who took my class 10 years ago, and I find people who are taking my class right now. Hello. And what I do is I just say on a scale of 1 to 10, how happy are you? So I have 3 different cohorts that I'm measuring at the same time. The right now, the 5 years ago, and the 10 years ago, right? And I'm hoping to see that they get happier as time goes on, right? So that's cross-sectional, multiple cohorts right now, people from 5 years ago and people from 10 years ago, but I'm measuring them at the same time. I just realized that there's a little typo. Cross-sectional is multiple cohorts, one time period. Oopsie. So longitudinal is one cohort over multiple time periods. So I take my one class that's happening now, and then in 5 years, I check up on you. And then in 10 years, I check up on you, right? So one cohort, just my class from right now. And then in 5 years, I measure your happiness. And then 10 years, I measure your happiness. Now, you might be wondering what the difference is. Well, if I do a longitudinal study and I'm going to measure you over the next 10 years, then how long is it going to take me to complete my study? If you said 10 years, you are correct, right? Now, you might reasonably go, oh, I have to wait 10 years to complete my study? Oh boy, right? So you might lean on the cross-sectional where you have multiple cohorts over one time period. And so I just find people who took my class 10 years ago, people who took my class 5 years ago, and people who took or taking my class right now. The issue with that is that there might be intrinsic differences in those people, right? So you guys might be less happy because you're taking this class during a really tough period, right? Can't think of anything that's going on in the world right now, but it might just be a real tough time. And the people who took my class 10 years from now might be happier because they just might have more financial security. So they're not as worried or stressed. So because there are these intrinsic differences between the groups, I might see a difference that's not actually because of the independent variable. The issue with the longitudinal study is not only that it just takes that long, but when I look back and then I'm like, okay, it's been 10 years, and I'm trying to make assumptions about what that means for people right now. So in 2030, when I'm teaching this class, and I'm like, okay, well, this is the data that I got from people who took the class 10 years ago, right? Will that data still apply to the people who are in my class? Once we have like cybernetic implants and like, there are aliens, and I don't know what else is going to happen in the future. Cars will be transformers, right? Will the data that I got from starting 10 years ago be meaningful in any way? So one solution is the sequential design, which is a combination of these two. So I have my multiple cohorts, so from 5 and 10 and now, and then I check in on you guys in 5 years, and then I check up on everyone in 10 years. So it's combining the multiple cohorts from the cross-sectional design and the multiple time periods from the longitudinal design. It solves some issues, but it creates other issues, right? So I still have to wait 10 years and I have to recruit more people, right? Because not only do I have to get people who are taking my class right now, I also have to get people who took it 5 years ago and 10 years ago. So by combining, you get rid of some of the issues, but you introduce new issues. So I'm going to use dogs to help illustrate this. So the cross-sectional method, I have multiple cohorts at the same time period. So right now, I'm comparing puppies to adult doggos, right? If you will see, like, look, the ears are smaller. This one's a little curved and a little floppier, right? You can see the jowls. There's all this extra doggo skin, right? Cute little upright tail. The fur is softer. The eyes are perkier and more alert, right? We're seeing the little eye slouch. Look at those big old doggo teeth, right? The jowls are descended a little bit. So I'm looking at two different cohorts, young dogs and big old doggos, right? And I'm comparing them right now. That would be a cross-sectional design. Or we could do a longitudinal design. So 15 years ago, I had one dog, or maybe I just had, let's just say, a whole bunch of puppies, right? And then I looked at them 7 years later, and then I looked at them 8 years later, right? And then I'm seeing how their behaviors change over 15 years. One cohort of dogs over multiple time periods. It took me about 15 years to do this study, and I was able to see how things changed over time. And now what I'm going to do is I'm going to look at current puppies and say this is how this disease is going to develop. If you remember the Tuskegee experiment, super unethical, but this was an example of a longitudinal study because they let people have syphilis and they just looked at how it developed over time. Oh boy, look at all these good old doggos. Oh, they're so happy, right? So let's say we took some puppers and some doggos, right? And we had little baby doggos and teenage doggos and adult doggos and old doggos, and we tracked them all over time, right? And then we checked in with them 2 years, and then maybe even 4 years. That would be sequential because I'm looking at multiple cohorts. So I'm looking at young dogs and old dogs, and I'm measuring all of them over multiple time periods. That would be a sequential method. Feel free to pause and decide who your favorite doggo is. I think this one looks like me. Last but not least, we have the quasi-experimental designs. They're called quasi-experimental designs because they are like the experimental designs that we talked about before, but they're just missing some of those basic characteristics. So they're really close to being full, true experiments, but they're missing some aspect of what we need for a true experiment. So remember, a true experiment has control of the independent variable. It has equivalent groups, and you measure the dependent variables. So we're going to be lacking one or more of those things. So the pre-experimental designs are the one group post-test only, the one group pre-test post-test. So these should seem familiar, right? If I remove the part that said one group, you go, oh, I know what those are. But the difference is now these only have one group. And then we have the non-equivalent control group design. Now, pre-experimental designs are a specific type of quasi-experiment which are so bad you would never want to use them in a study. I know what you're thinking. Well, why are you teaching us about them? Because people use them and they rely on them, not realizing how flawed it is to use them. So you want to be careful if you see somebody using this type of justification because it's not actual scientific research, or at least it's not Quasi-Experimental research. So one form of pre-experiment is the one group post-test only. So I find 30 people and I give them a diet, right? And then on average, everybody in that group lost 15 pounds over the next 2 months. Woo! Pretty impressive. Does that mean that the diet works? I'm waiting for a response and I just realized that I'm alone in my room and it got really sad for a second. But just because people lost weight, does that mean that the treatment worked? Does that mean that the diet worked, right? In an experiment, you would have a control group. And you might see that people in the control group also lost 15 pounds on average, right? So if you don't have any comparison group, first of all, you don't know where they were to begin with, right? If they weighed 750 pounds and they lost 15 pounds, you'd go, well, that could happen, right? Without any specific intervention. So not knowing where they started and not having anyone to compare them to makes it pre-experimental. But you'll see lots of treatments use this, right? Well, I gave this person this thing and they felt better, so it works, right? Well, compared to what? There's no comparison group. So if you don't have equivalent groups, and if you only have one group, you don't have equivalent groups because there's only one group, so you can't compare it to anything, right? Then you can't say that your results are in any way meaningful. So the one group pretest post-test tries to fix this a little bit, where you measure them at the beginning and then you measure them at the end, right after you give them the intervention, right? So, I started feeling sick, so I took some airborne and I felt better later. Great. That doesn't mean that the airborne worked, right? So we do all these things when we're sick to make us feel better, and then we do feel better, and then we go, that is the only cure that I will ever depend on. That is the only thing that made me feel better. If I didn't do all these things, I wouldn't have gotten better on my own. The only reason why I got better is because I took airborne, or because I got antibiotics, or because I did a whole bunch of vitamin C and zinc, or because I did a cleanse, right? Those things only seem like they work because of this, right? We felt better. So it was related to us getting better. We did take it and then we did feel better, but it's not causal, right? We can't say that just because those two things happened around the same time, that one thing definitively caused the other. So, especially with the one group pre-test, post-test, there are a few issues that we need to be aware of. So here are the issues that we should discuss. We have the history effect, which refers to external events that affect the dependent variable. We have the maturation effect, which are internal changes that affect the dependent variable. We have the testing effect, which refers to the fact that when we are being tested, that's going to affect how we respond on the dependent variable. We have instrument decay, which refers to the fact that our tools that we use to measure the dependent variable can become less accurate over time. And then we have regression to the mean, which is the idea that extreme scores over time become more normal, right? So I measure you guys in 3 weeks on a measure of stress, right? So 3 weeks from now, I give you a test that measures stress, and then you are very stressed, 10 out of 10. 3 weeks later, you are less stressed, 6. Now, I gave you some like a magic marker. It's a magic marker that if you hold it, it will make you feel less stressed. So you went from a 10 to a 6. Now, Some of you might go, oh, let me get one of those magic markers, right? If I went from a 10 to a 6 in stress, I will pay top dollar. Don't be a fool, right? What's happening in a few weeks? Could it be your final exams? Some of you might be a little stressed about those, right? After your final exams, some of you might not even be taking summer classes, so you might be significantly less stressed. So the thing is, the fact that you had finals and then later you didn't have finals means that some external event, the presence of your final exams, affected your scores on the dependent variable, not the independent variable. In a similar way, sometimes we just change internally. It could be something biological. We were hungry and now we're less hungry, right? Or sometimes it's based off of our motivation. Let's say you were doing a smoking cessation test, right? Or trial. So it's a program that's going to make you quit smoking. Now, if you're in a program to help you quit smoking, you're probably already at a point where you want to quit smoking. So at the beginning of the study, you're like, smoking 10 cigarettes a day, and you're like, I really wish I were smoking less. So day by day, you start smoking fewer and fewer, not because of the program, but because you personally have changed internally, right? So when there are internal changes, that's the maturation effect. A similar thing can happen, which is called the testing effect. When we're aware that we're being tested, our behaviors change. So let's say it's something like maybe you bite your nails, right? And you're doing this program to help you bite your nails less. If every time you bite your nails, you have to write down that you bit your nails, you're going to be much more aware of the fact that you're biting your nails, right? So when sometimes if you have like a bad habit, you do it without even thinking about it. But once you start thinking about it, you go, oh, I'm about to bite it. And then you might not do it. So because you're being tested, you might see changes in the dependent variable, not because of the independent variable, but just because you're being tested, right? If you're being measured on anxiety, you might feel less anxious or you might feel more anxious. Another issue is instrument decay. The tools that we use to measure things get less accurate over time. Sometimes the tools that we use to measure things are people. So if I have to count every time a child acts up in class, right, and I'm seeing if a specific program helps reduce the amount of negative behaviors in a classroom, beginning of class, it's easy for me to remember every specific time that something happened. 4 weeks into the semester, I'm like, oh, yeah, I think somebody did something on Monday, but I'm not really like. So over time, my accuracy in keeping track of certain behaviors I'm trying to measure, it's going to get worse, right? Or if you're keeping track of the number of, if you've ever counted calories, right? The first week that you do it, you remember every single thing that you've eaten, right? The second week, you go 2 days without having counted, and you're like, uh-oh, what did I have for lunch yesterday, right? So you get less accurate over time. Then finally, we have regression to the mean, which is the idea that extreme scores become more normal over time. So let's say I have a really terrible cold, right? So I go to an alternative medicine doctor because I'm sick of Western medicine, and they give me a special tea that's going to help me get better, right? Now, if I did nothing, if I have a cold and I do nothing, what is going to happen? One of you thought get pneumonia, and you were a pessimist. That's very unlikely, but okay, I see where you're stepping. But if you do nothing, right, as long as you're not exhausting yourself, if you have a cold, you will eventually get better. That's how it works, right? You feel it for a few days, and then you get better. So that when you're at your worst, when you're at that point where like, oh my God, I'm really sick, I should do something, At that point, it's probably not going to get worse. The only place it's going to go is it's going to get better over time, right? So if you do something like take a special tea or, I don't know, meditate on it, or, put a crystal in your pocket, whatever thing you do, not to say that crystals aren't super cool, right? But that's not the thing that's making you get better. Your body would have gotten better anyway, because any extreme score is eventually going to drop down and become the average, right? So these are things that we need to be aware of when we're doing a one group pre-test, post-test, because not when we're doing, but when other people are, because you might see, oh, they did this thing and they were feeling this way and now they're feeling this way, so it must work. But it could be any of these reasons. Any of these reasons could explain why they're seeing an effect, heavy air quotes right there, of the independent variable and the dependent variable. And finally, we have the non-equivalent control group design, where you have two groups and no pretest. You give the treatment to one group, another group gets no treatment, and then you compare the results, right? The issue with this, you now have two groups, so that's great, but the groups are not equivalent. So sometimes what ends up happening is you have two groups that have already been formed and you want to compare them, but you can't make them equal. So let's say an example of this would be comparing two classes, right? One class gets new computers, the other class gets older computers, and then we compare the average scores at the end of the semester. Well, we don't know how the classes were before. If the class that was already super smart gets better technology, and then we say, oh, look at how high their grades are, well, it might not be because of the technology. They could have just been smarter to begin with. So a non-equivalent control group design is problematic because you don't know if your groups are equivalent. You need to be able to compare equivalent groups. But now we can talk about the actual quasi-experimental design. So these aren't perfect, they're not ideal, but if you can't control the independent variable, or if you can't really make sure that your groups are equivalent, then you have the ability to go, okay, well, these are still ways of getting good information. So we have the non-equivalent control group, pre-test, post-test design. We have propensity score matching of non-equivalent treatment and control groups. That's everybody's favorite. Everybody loves propensity score matching of non-equivalent treatment and control groups. Then we have interrupted time series design and control series design. So you're saying to me, Professor Thompson, we just talked about a non-equivalent control group design, and you said that we couldn't use it because it wasn't equivalent. But this is a non-equivalent control group pre-test, post-test design. So by starting with the pre-test and then having a post-test, we can see how the groups were at the beginning, and then we can measure them at the end, right? So this pre-test, we can compare it to the post-test. So the great thing about this is, even though my class and somebody else's class might be different to begin with, I can still see by how much they've changed from the beginning of the semester to the introduction of the treatment, to one group, to the end of the semester. I took this image from the internet and I just noticed that there's a little typo, and that's why you never steal images from the internet. A slightly fancier way of dealing with non-equivalent groups is what's called propensity score matching. Propensity score matching is when you take people with specific characteristics, and you make sure that they are equally represented in each group. So let's say I'm trying to pick a basketball team, right? There are two characteristics that affect how good you are at basketball. One is your height, the other is your current skill at playing basketball, right? Maybe there's a third thing, but let's just say that there are two things, right? So what I want to do is make sure that there is a balance of tall people who are good at basketball, tall people who are terrible at basketball, short people who are good at basketball, short people who are terrible at basketball in each group. So what I do is so what I might find is that in one class, there's only one tall person who's good at basketball, and in the other class there are two. But because those are equivalent scores, I'm going to compare one of the tall people to the who's good at basketball to another tall person who's good at basketball. It can get really heady and trippy, but all you need to know is a propensity score is just a way of making sure that your groups are equivalent. So you take characteristics that you feel are important, you match people in each group, and then you compare those matched people. So if I have 5 honors students in my class and I have 5 honors students in the other class, I make sure that I compare their scores to figure out which class is doing better. Propensity score matching. So sometimes you want to see how things look in large organizations, or in even in things as big as like a city or a state, right? If I'm trying to figure out how to enact a specific law or whether or not to enact a specific law, I might look to other countries, other cities, other schools to see what happened when they did that specific thing, right? Or if I have already done it, I might look to see if that thing was effective. So let's say I wanted to see, so here's the example that we have. We're looking at the rate of property crimes, right? So this is what property crime looked like before early TV was adopted in some cities. And this blue line represents cities that adopted TV early. And we can see that the data was increasing, but also once they adopted TV, there was a spike, right? So the property crimes continued to increase. So what we're assuming is that the introduction of TV is related to property crimes, right? So that is an interrupted time series design. Let's say we were looking at general student happiness at Citrus College. Recently, we banned cigarettes, right? So if it looked like this, right? And then once cigarettes were banned, it looked like this, then we would say, oh, for sure, right, the banning of cigarettes increased student happiness. If we're looking at a chart that looks like this, and then after banning cigarettes, it looks like this, right? Then we're like, oh, why did we ban cigarettes? Students love cigarettes. So by looking at an interrupted time series, we look at the time before, we look at the time after, and then we just see if there's a difference. It's like the A-B design, but on a larger scale, right? So we're not just dealing with a single case, we're dealing with something as big as an organization or a city or a country. Interrupted time series design is what's being used to track COVID-19, right? So we're looking to see how it looks over time. We say we're going to enact these specific measures, and we're hoping that the rates of infection go down. That's what we mean by flattening the curve. It could go like this, right? but we're trying to make it go like this. And we're hoping that by intervening right here, we're seeing a decrease in the number of new infections. And then finally, we have a control series. So sometimes you don't want to make the change, but you want to see what happens when somebody else makes the change. So let's say we have two classes, right? And they're both teachers want to see if there is a way to change the amount of absences that occur in the class. So the other class enacts a new policy where every time you're in class, you get a piece of candy, right? Free candy for every time you're in class. The other class does not enact that, right? So we can see how things are before in each class. And even though after this class is introduced to candy, we see that on average, right, this class with no candy, the absences stayed about steady, even increased on average, right? But this class, on average, decreased, right? So I can say, well, if everything was the same for both of us, aside from the fact that they just introduced candy to their class, then if I introduce candy to my class, then that's the right thing to do. Again, this is what we've been doing with COVID-19, right? Other countries got infected first. We look to see what their curves look like, right? Okay, they enacted stay-at-home measures and they saw a decrease in cases. This country reopened too early and they saw a really big spike. And so so because we can compare our curves to theirs, we go, okay, well, if we're right here, if we change things, then we'll go up here. If we don't change things, then we'll stay down here. By the way, this is 20 billion deaths. So that is everybody on the planet dying 3 times. That wasn't a great exponential curve. So that is a control series, right? I'm comparing myself to some other big group, and they introduce the treatment. I don't introduce the treatment, right? That's why it's a control series. And by introducing the treatment and us not introducing the treatment, we can compare what happens in their group to what happens in our group. And then if there is a difference, then we can say that it's probably because of the independent variable. So that is the last quasi-experiment. Just know what these things are in general. If you can look at 2 of them and see what the differences are, you'll be good to go. We'll review this during office hours just to give you a little extra exposure, but all I really want you to do is be able to, if I were to give you a description of one of these, you'd be able to know, oh, that's a cross-sectional design. Oh, that's ABA. Oh, that's a propensity score matching of non-equivalent treatment and control groups, right? So that's it. We did it. Have a good day. Get some rest. I'm just going to assume that's real late for you. So you could be listening to this right when you wake up, but I'm going to assume that it's real late. So get some rest. Go back to sleep. Take care.